Hi everyone. Today I'll be showing you how to square numbers that end in 5. And I'll also include a derivation of the rule. If you want just the application of the rule, I have a link below in the description that you can click on that will only demonstrate the application of the rule. So let us begin. Step 1 of the rule. Step 1 says that the last two digits of the result is always going to be 25. So for example, if we have 65 squared, the last two digits of the result is going to be 25. Step 2, the more complicated step. So the beginning digits of the result is going to be a times a plus 1 for a5 squared. A here is the first digits of the number a5. So perhaps an example will help clarify things. So if I have 115 squared, a will be 11. Why? Because if we look at this a5 squared and look at 115 squared, we can see that 5 matches with 5 and a is going to match with 11. So that's why a is 11. Similarly, continuing our earlier example of 65 squared, we can see that a is going to be 6 for the same reasons. 5 corresponds with 5 and a corresponds with 6. That's why a is 6. So, using this rule above here, it says the beginning digits is a times a plus 1. So for 65 squared, a is 6. So the beginning digits is 6 times 6 plus 1. Simplifying a little more, we can note that 6 plus 1 is, 7. So we have 6 times 7. And so we know that 6 times 7 is 42. And so the final answer is 4225. Or 4,225. Now for the derivation. We can note that we can rewrite a5 as 10a plus 5. Recall from perhaps elementary school that 5 is in the ones digit and a is in the tens digit. This is why we can rewrite a5 as 10a plus 5. Also recall, perhaps from pre-algebra or algebra class, that x plus y, the whole thing squared, is x squared plus 2xy plus y squared. Using this above rule, we can rewrite a5 quantity squared as 10a plus 5, the whole thing squared. We can then use this rule to expand this expression, as we will show in the next page. So here we have 10a plus 5 squared, and we are expanding it. So we have 10a whole thing squared plus 2 times 10a times 5 plus 5 squared. Simplifying this expression, we can note that 10a squared is equal to 100a squared, and 2 times 10 times 5 is 100, so this term becomes 100a, and 5 squared is 25. Further, to get to the last step, we can note that 100a and 100a squared and 100a both share 100a. So this means we can factor out 100a from this term and 100a from this term. So if we factor out 100a from this term, we have 100a times a. If we factor out 100a from this term, we have 100a times 1. So these first two terms can be rewritten as 100a times a plus 1. And then we also have the plus 25 as residue from the previous step, plus 25. And so we are pretty much done now. So using this result, we can note the last two digits are always going to be 25. The reason why is because we have this a times a plus 1 multiplied by 100. This means that this particular quantity will never affect the 10th digit or the 1st digit. It will only affect the 100th digit and perhaps the 1000th digit or 10,000th digit and so on. So this leads to the last two digits being 25, since 25 alter only the 10th digit and the 1st digit. So the last two digits are 25, and the first digits are going to be a times a plus 1. And so this matches with the rule that we discussed earlier, and well, we are done. Thank you.